So good evening everybody, it's from Jayshree. I am going to take this configuration of an opamp under operational amplifiers. Okay, so let us see what I mean by configuration of an opamp. So there are two configurations of an opamp. Number one is what? Open loop configuration and closed loop configuration. In open loop configuration, there is no feedback from output to input. The differential signal present between the inputs will be amplified by its open loop gain. So AV is equal to 2 into 10 power 5. Okay. Next one. Therefore, even for small magnitude of differential voltage, output will reach positive or negative saturation. This is what open loop configuration of an opamp. That is opamp negative sign, plus sign. Here V2, V1 both are minus together to form this V0, AV minus V2. Okay, this is what this open loop configuration. Okay, why is opamp is not used in amplifier in an open loop configuration? Due to very open loop gain, distortion is introduced in the amplified output signal. The open loop gain does not remain constant but varies with temperature and power supply as well as due to MOS production technique. The bandwidth of an opamp is very small, almost equal to 0. For this reason, the open loop opamp is not used in practice as an amplifier. So next, let us see what I mean by closed loop configuration. In the closed loop configuration, the feedback is introduced as the part of the output is fed back to the input. There are two types of feedback present in the closed loop configuration. Number one is what? Positive feedback or regenerative feedback. Number two, negative feedback or degenerative feedback. Okay, I will repeat this: positive feedback or regenerative feedback, negative feedback or degenerative feedback. Positive feedback: if the feedback signal and the input are in phase with each other, then it is called as the positive feedback. It is used in applications such as oscillators, Smith trigger, and regenerative comparators. Okay, negative feedback: if the signal fed back to the input and the original input signal are 180 degree out of phase, then it is called negative feedback. In application of opamp as an amplifier, the negative feedback is used. Here the negative feedback indicates the minus sign is given to this V2 and plus sign is given to this V1 non-inverting terminal, and both are connected together to form the RF feedback signal, feedback resistor, and finally we get this closed loop configuration. Okay, so there are advantages of negative feedback. It stabilizes gain, reduces the distortion, increase the bandwidth, reduce the effect of variation in temperature and supply and voltage on the output of opamp. Thus only the advantage of negative feedback is low gain. Okay, I will repeat this. There are two configurations of opamp. Number one, open loop configuration. Number two, closed loop configuration. In open loop configuration, there is no feedback connected from output to input. The differential signal present between the inputs will be amplified by its open loop gain. Okay, next one. For every small magnitude of the differential voltage, output will reach positive or negative saturation. Why the opamp is not used as an amplifier in the open loop configuration? Due to very open loop gain, distortion is amplified in the output signal. The open loop gain does not remain constant but varies with temperature and power supply as well as due to MOS production technique. The bandwidth of an opamp is very small, almost equal to 0. For this reason, The op-amp is not used in practice as an amplifier. In closed loop configuration, in the feedback is introduced, the part of the output is fed back to the input. The feedback can be of the following two types: positive feedback or regenerative feedback, negative feedback or degenerative feedback. In positive feedback, if the feedback signal and the input signal are in phase with each other, then it is called positive feedback. It is used in applications such as oscillators, Smith triggers, or regenerative comparators. In negative feedback, feedback is connected to this input and the original output are 180 out of phase, then it is called negative feedback. In application of an op-amp as an amplifier, the negative feedback is used. So these are the advantages of negative feedback. It stabilizes gain, reduce the distortion, increase the bandwidth, reduce the effect of variation in temperature and supply voltage on the output of the op-amp. The only disadvantage of negative feedback is low gain. So thank you all. Let us see the next class in detail.